So this is a video on applying the things we learned from that transformation grid that I showed in the last video. And really the best way to do this, because this worksheet is posted on Canvas, is I would say that you should maybe watch me go through a couple, and then pause the video, do the next couple, and then watch me work through it, and then pause the video, do the next couple, etc. So here we go. Start out with this, identify the parent function, and then give the sequence of the transformations done to it. So at this point, you should have the 9 parent functions in your mind, or both the equation and the graph. In my face-to-face class, they actually just took a quiz today in class where they had to write down the parent function, the 9 parent equations, and sketch the graphs from memory. So I can't really do that with you guys because you're online, and I'm not going to make you come in and do that and stuff. But that's something that you should be keeping in mind. That's kind of the level that you need to understand those parent functions. So if you've done that, or you're working towards that, then you should be able to look at this and see, because of the squared, let me grab a drawing here, because of the squared right there, that's the main thing that's happening to this function. We know that the parent function of this guy is y equals x squared. So that's the first part. Identify the parent function and then give the sequence of transformations. So then we look at this and notice that there's really a couple different things going on here. Let's pick yellow, yeah. There is the minus sign, and then let's pick a different color. There's the half, pick a different color like blue, and there's the +8. So we need to identify what each one of those things are doing. So we'll start out with the yellow. So if you look on that grid, we know that negative and that's on the outside of the squared. That means it's going to be a reflection. I'll grab this. So that would be a reflection across because of the outside, that means the y's are going to be affected, so that would be across the x-axis. Okay. So then we go to the green. It's fun with highlighters, isn't it? So the 1/2, that's multiplying by 1/2 on the outside. So if you look on the grid, that would be 1/2. Multiplying by 1/2 on the outside, that'd be a vertical stretch of 1/2. So we're going to say vertical, and because it's on the outside, it behaves just like we think. Vertical stretch by 1/2. And then finally, we got to figure out what happened with the blue. Boom. Boom. And with the blue, we're going to have, that's adding on the inside. So that means it's going to be a shift. And it'll be, because it's adding, remember we have that opposite effect going on there. So that'd be shift to the left, 8. And that's it. So I'll do number 2 real quick here. Identify the parent function and then give the sequence of the transformation done to it. So the parent function is y equals the square root of x. Of course, you can pause this video at any time and try to stay ahead of me. So, whoops, I left off a y equals there, didn't I? That's embarrassing. Or an f of x equals. So, looks like, once again, I'm not going to go through all the colors, but, well, I guess I will. There's a yellow, there's a green, and there's a blue. Okay, now this is a tricky one because there's both a reflection and a shift going on the inside. So let's first of all, we'll handle that 3 on the outside because it's on the outside. So that's a 3 multiplied, that's outside the square root, so that's how we know it's on the outside. So we're going to take that, that means that 3 is going to produce a vertical stretch by a factor of 3. Now, on the inside, we have to be careful with this because we have to make sure it's in the right form. So when I'm looking, if there's a reflection and a shift going on in the inside at the same time, then I have to, what I need to do is factor out the effects of the reflection. So right now there's a -1 there. So another way to write this equation would be y equals 3 times the square root of negative x minus 2 plus 5. Does everyone see that this function and that function are the same thing? They're just written with the negative factored out of the plus 2. And this is really the form that you want it in to be able to tell what actually happened in the shifting. Because notice this would make me think that I'm shifting to the left 2, but actually what happened is it got shifted to the right 2. And we need to see it in this form to be able to see that. Okay, notice it doesn't matter as far as the reflection goes. That's still a reflection on the inside because it's inside the square root. But the if we're going by the rules of the grid that I showed you, this is actually going to produce a shift to the right 2. Okay, so the green tells me that I'm reflecting across the, because it's on the inside, that means the x's are affected. So I'm going to go across the y-axis because that'll affect x values. So across the y-axis. And then finally the blue, after we put it in the right form up here, right? That's a -2 on the inside, which means it's going to shift right 2. Okay? So at this time, I would recommend that you pause the video and try 3 and 4, and then come back and check and see how you did. But I am going to keep going. Okay, so this would be, parent function here is y equals square root of x. Once again, notice you see the negatives mixed in there, so we'll have to be careful of that. So the 1/5 is going to produce a vertical stretch by 1/5. Now, I don't want to cause confusion here. This is actually going to end up producing a compression, but I just use the word stretch and then the factor tells me whether it's stretching longer or stretching shorter, which I know that's kind of a weird thought sometimes, but if you start using the word stretch and compress, it gets confusing because the factor actually plays in. If I say I'm compressing by a factor of 1/5, that would actually make it longer. So anyway, I don't want to confuse there. So I'm always going to use the word stretch, and this means that it actually is making things shorter. Vertical stretch by 1/5 means that it's 1/5 as far away from the x-axis. So if I had a vertical stretch by 5, that means it's 5 times as far from the y-axis. Okay, and then next we have a reflection, a negative on the inside, so that's going to reflect across the y-axis again because it's on the inside. And then we have some shifts going on. So once you factor out that negative, we see that's a +1. So that's going to shift it to the left 1. And then finally it's going to be a shift down 3. Number 4, let's see, that's the parent function is y equals 1 over x squared. And we got several things going on here. It looks like we have a 3 up top. So it might be helpful to think of this as f of x is equal to 3 times 1 over x squared, because then you can see that the 3 is being multiplied, right? Otherwise, there's no way I can turn a 1 into 3 without, I mean, that's a way to turn a 1 into 3 is by multiplying by 3. Excuse me. So that means we have a vertical stretch by 3 because of that guy. And then, and the only other thing that's going on is the -3, and that would produce a, whoops, I'm not going to say vertical because I'll just say shift down. So that's going to be a shift down 3. Okay, once again, I would suggest that you pause the video and try number 5 and 6, and then once you've got them done, come back and check and see how you did. So here we go, identify the parent function. The parent function is absolute value of x, and we got a 2 going on in there, a 2 going on in there, and a 4 going there. So the first 2 is going to produce a vertical stretch by 2. The second 2 is, the second 2 is going to shift to the right 2, and that 4 in the end is going to shift up 4. Okay, number 6, identify the parent function and then give the sequence of transformations done to it. So first of all, the parent function is y equals x cubed. And we can see we have 1, 2, 3 things to worry about. So that first one, the negative, that's going to reflect across. Now we're on the outside, so that's going to affect the y values. So that means I'm reflecting across the x-axis. And then we have a shift to the right 2, and a shift down 5. Great. Now this one's a little bit different. You're given the equation, the parent function, and telling what's happened to it. So the way I'd like to do this is I would say y equals, now I know that's going to be something, so there's something on top divided by something squared. And then put everything in the right place. So if it is reflected across the x-axis, that's affecting y values, so that means it should be on the outside. So that's going to be a negative on the outside. And since I'm not multiplying by anything, this would still be 1. And then the only things left now is the shifts. So if I was to do this, so and then shift to the left. So if I were to shift it to the left 5 units, that's going to happen down here where I'd go x plus 0.5, right? So you can see how those match up. And then we also need to shift up 2.5 units. So that's going to happen out here, right? And so that would be plus 2.5. Okay. And so here we have again, we have a y equals, and they're going to be something inside an absolute value. So this is reflected across the y-axis. Now here this is debatable. I could say I don't really have to do anything, because if you reflect the absolute value function across the y-axis, we know, because it's an even function, there wouldn't be any change, right? Think about the graph itself. Looks like that. So if you reflect that across the y-axis, it'll land on itself. So you could put a negative on the inside if you want to, or you could just leave the negative out, because really I don't need to do anything in the equation to make this function look like a reflection of this function across the y-axis. Okay, so I'm just going to leave the negative out for now, but you understood, hopefully you heard me explain why. Okay, now if it's stretched vertically by a factor of 3, that means I just need to multiply by 3 on the outside, so it'd be a 3 out here. And then shift to the right 5, that's on the inside, so that would be x minus 5, because subtracting 5 caused me to shift to the right. And that's it. This is what would the new equation be. Okay. Again, I would suggest that you pause the video, try the next couple, or next maybe 9 and 10, and come back and watch the video. So this is going to be y equals something cubed. So it is reflected across the x-axis. So that affects y, so that means there's going to be a negative on the outside. And then shifted to the left, so that means there's no multiplication, so I can just make that negative a little bit longer. Then it's shifted to the left 1, so that means I need to add 1 on the inside, so that'd be x plus 1. Then shifted 2 units down, so that'd be a minus 2 on the outside. Okay? Given f of x equals 1 over x, if it is reflected across the y-axis and then reflected across the x-axis. Ooh, double reflection. Whoa. Okay. So I got y equals, we got a negative on top and a negative on the bottom. Now let's stop and think about this for a second. If I have a negative on the top and the bottom, is that really going to do anything? Don't a negative on the top and the bottom cancel out? You're right. So why is that? Well, if you think about what this graph looks like, if I reflect across the y-axis, it's going to end up over here and here. Then if I reflect across the x-axis, it'll end up right back where it started. So essentially, by reflecting across the y-axis and the x-axis, nothing happened. So this is like the one we did a couple of minutes ago. I could get away with not putting any negative anywhere, because actually, algebraically, that's what's going to happen anyway. But also, if you think transformationally, reflecting across the x and y axis essentially puts it back where it belongs. Okay? And actually, that's just as a side note, remember that this is an odd function, and if you rotate 180 degrees, it lands on itself. Reflecting across the y-axis and then the x-axis produces the same result as rotating 180 degrees. So that's a little side note. Okay, so what do we have to do left? Stretch vertically by a factor of 3. So really, if I multiply the top by 3, that's the same thing as multiplying the outside by 3. So 3 times 1 would be 3. And then shift down 5 units. So I'm not shifting to the left or right. So I just put an x underneath, and then I put a minus 5 outside. Okay, and last but not least, again, right now, I'd suggest you pause the video, try your hand at 11 and 12. And once you think you've got them, come back and watch the last bit of the video. Okay, here we go. So we got to start out with y equals something over something squared. It's stretched vertically by a factor of 5. So that means 5 times 1, of course, is just 5. Shifted to the right 3. So that would be x minus 3 on the inside. And then shifted 4 units up. That'd be plus 4 on the outside. Did you get that one right? Woohoo, if you did. If not, hopefully you can figure out what you did wrong, or send me an email and ask me. Okay, and then finally, last but not least, we have y equals something squared. That's what the parent function is telling me. Is stretched horizontally by a factor of 2. Aha! I'm glad I put this one in here. If I'm stretching horizontally by a factor of 2, that actually means I'm multiplying by 1/2 on the inside, or divided by 2. So you could write it like that, or you could write it like this. Because remember, we have that reciprocal effect going on the inside. So that's how you'd stretch it twice as far away from the y-axis. Okay, then it says shift to the left 1 unit. Whoops, I got to incorporate that in. Shift up 3 units, so I can throw that in easily. That's a plus 3 out there, right? So on the inside, I'm going to have to redo that, because remember, if we have a inside shift and stretch going on at the same time, we have to be careful about that. So the way you do that is put the 1/2 factored out. Then on the inside, I'm going to, let's see, it's shifted to the left 1. So I would put x plus 1 in there. That's how we'd handle that. Okay, and that's the conclusion of this worksheet.